Okay, good afternoon, guys. So, you guys are all good with the theorems, right? All the theorems and all the properties. Master Janif must have enlightened you with all this, right? So, today's lecture won't be too long. I will try to keep it really short because I know you guys all in that holiday mood now. We'll just be doing some expression like breakdown, right? The ones we have done in tutorial. Just some minor ones, and then we can all go. Right? Okay. Have you done construction of XOR gate? Anyone? Construction of XOR gate? No, not yet. No? Wait, okay, hold on. Have you done this? Not yet. Pardon? Done? Do you guys write notes? So you have done it or not? Done it? Okay, yeah. That's all I was asking. Okay. So let's simplify some Boolean expressions for today, okay? Okay, so that's our expression, right? It's A and B, or of A and B, that's inverted, right? I made a mistake, sorry for that. And C plus, there's three inputs of A, B, C, where the B and C are inverted, right? So let's see what are the theorems we're going to use, what are the properties we're going to use, and how we're going to simplify that expression, okay? So basically we can see right now that the variable A is present in all, okay? Variable A. Have you noticed? Yes, sir. Right? So, just as your MI units, you can simplify that, right? So, you'll be getting B or B inverted C plus that. Do you get that? Right? Now we'll be using, we can see B or B inverted C, right? This is the theorem of 5, I think. It's theorem 5. Oh, there you go. Right? It's A or A inverted B. This comes as A or B. So now, if you see the same thing for here, right? That's the same thing. So we're using theorem 5 here. And we're basically going to get B or C plus that. Okay? Now, we can still play with our B variables. So we'll be doing the shifting method, okay? Shifting method. Yes. Okay. Why I did the shifting method here? Because I'm going to be reusing that theorem 5 again. So in this case, we use B or B inverted C, and we got B or C. Here, we're going to be using theorem 5 again. This time you'll get B or C inverted. Okay, do you get me? Right, we're just playing around with the theorems. All good till there? Okay. Now, we're going to be we can see C inverted or C, right? This is the complement theorem or complement law, right? Just let's look at that first of all. Where is the complement law? Oh, here. Okay. A or A inverted, right? That is same as 1, right? And A inverted is same as 0, right? It's equated to 0. So let's move on for our simplification. So this directly goes to 1, okay? You guys can see, right? 1. Now we have A variable on its own, the input, and in the brackets we have B or 1, right? B or 1, we can satisfy with the null element property, okay? Where it states that any variable input with the or Boolean expression will just give you 1, okay? Here. Okay, this is the null element. So now we just left with A and 1. This is same as A, okay? So basically, from such a big expression, we have simplified to just A, okay? The input A. So that's how basically the theorem, the shifting the properties work, okay? So that was one of the simple ones. I would like you all to at least go home, okay? And within this break, try to do this again, okay? Without looking, and see if you can identify which theorems to use where, okay? It's really important. You guys need to know this. Okay, I'll give you 1 minute to copy. If you're done, then I'll move on. Okay, let's move on to our next example, right? So this is basically our next example. It has 4 expressions of O, and then and those are collaborated with the AND gates. Okay. So how are we gonna be simplifying this? So basically this portion, okay, this portion is similarly with the element of this. Okay, it's almost similar to that. So let's break it down. I mean, not break it down, simplify. So this will be similar to A, B. I'm just thinking of this C as B naught. Okay, right? So in this place it was BC. So here it will be B and B naught. Okay, I hope you get it till there. And similarly for this, so both we're gonna be using this. Okay, here it would become A naught or B naught again. Right? Simple. So now we're gonna be using the complement law. Which is A bar equals to 0, right? So G equals to, this will become 0, this will become 0, right? We'll be left with A or 0, A bar 0, right? So 0 doesn't have to do anything, like doesn't have any objections to that. So just move on to A and bar. So this collaborates to this complement law. So your G will just be 0 in this case. So that's your total simplified expression. Okay. Please quickly copy this so we can move on. Set? All good? Okay, we just have 5 more examples to go and then we can end this class, okay? So this is our new expression. Quickly write this, please. So in cases like this, where you see an expression with the same inputs, like 3 inputs here and 3 inputs here, so you try to shift them together, okay? Shift them closer together so you can group them. Definitely they're going to be grouping. So something like that, or you can leave A bar on its own for now. So now we can use the distributive law here. If you go and look in your notes, distributive law. We can see that A and C are present in both, so we're going to take out A and C, okay? A and C will go out, and you'll be left with B or B bar, okay? Now that makes our expressions much more simpler. From here, you can already know that something is going to be cancelling off from here, B or B bar, right? B or B bar is the complement law. Right? This portion. So now it's much more simpler. You are left with A and C plus A bar, right? Now you can see the variable you can see the variable A, okay? Oh wait, you can use theorem 5 here. Let's look at theorem 5 again. Okay, yeah, we can use theorem 5 here. So we have this same A input with our B inverse, right? So theorem 5, this will be same as A bar plus C, right? That's the final expression for this. Any confusion here? All good? Set? You guys, why are you talking so much? Okay, let's move on. So expressions like this, okay, these seem much more complex, but actually in these cases you will have to look for inputs, right, which are similar in all the brackets. So from here, can you tell me which inputs are like present in all the brackets? A N? Yeah. Okay. How about two brackets? Any of the two brackets? Which are the two? A and C. Oh, okay, okay. You see C here, right? Okay. Yeah. Okay. So let's take one of them. Okay. I would like to take AB and AB from here, right? Let's do the shifting first. Right? Now you can say let X equal to A or B. So basically So basically we'll be just replacing A or B with X, right, to make our work easier. We cannot change this, okay, because it's B bar, right? So we leave that alone for now. Now you can already see a theorem we can use here, right? We can use the complements law or the property, okay? Because we already have one X, one input, which is, yeah, present in both. So we're going to be using the complements law, and you can see how it changes. So you'll see that it changes by X or C bar. Right? Now this is same as 0, the null element. Right? You'll be left with X plus 0, A, B plus C. Set. So O of 0 is basically nothing, right? So you can directly have X, A, or B bar C. Now we can change our X back to our A or B, right? A or B. A or B, or C. Okay. Okay, so here we're going to be amending a new property, right? Not amending, we'll be just playing around. So you guys already know of A plus B. What else? Into X plus Y, something like that, okay? Not really, I made a mistake, I think. A plus B. Yeah. Pardon? I don't condense. Yeah. This one? You're talking about this? Which theorem is that? This one? You meaning here? Idempotency. So which place you want to use that? Here? Yeah. Now, oh, that. No, that will make your system more complex. Yeah, because like A or B, right? Bracket, and then it's gonna keep on expanding. So it's gonna be a much bigger expression, right? So I was thinking of this. You see A, right? That's one input. Here, we're gonna make this as one input. So this as X, this as Y, right? Just see how this changes, okay? So this basically will change as A as X, or our Y will be B or B bar plus C. That's how the expressions change. Okay. Now you can do the expansion, the one you were saying, right? You can play with your set. So you'll get A, B bar, B C. Now this will change as 0. You'll be left with A, B, C. And that's finally it, okay? So when you have an expression like this, that's how you're going to play with it, okay? You'll consider x and y. So you'll have to just manipulate with your y or your x, okay? So see, I considered for this expression y is that, for this expression y is that, because we already had a the similar or same variable. So it's okay, you can play with it. Set. Don't try to expand, okay? If like you have two brackets, don't try to expand like MA. Yeah, it's gonna make it more complex. That's why we have theorems. So try to copy this fast. We have just another 2 examples to go. Yeah. A plus B. Oh, this one? No, sorry. I wanted to explain something, but I messed up. Yeah. You mean this one? Yeah. How do you identify when to use it? Okay. So you have two brackets with you, right? So you just see in those 2 brackets if one of your variables is the same. So you see these 2 brackets right now? You see A or B, right? And the other one is A or, yeah, set. This is basically like that. So you have the similar ones, right? So you just consider this as xy, consider this as x, this whole thing is y. Set? Yeah. Okay. So basically that's a trick, right? So after that you will have this, right? And then you'll be able to take it all to 0 by a null and one. See? Yeah. That's the only way actually. You'll get familiar with it. Don't worry. With more examples. Any more questions? I hope we understand, right? It's okay? You guys this side? All good? Set, can we move on? Okay. Okay, so there's another law. When your 2 inputs and the whole thing is inverted, and you try to, oh, sorry, right? Okay, yeah, like this. If you have your 2 inputs and the whole thing is inverted, and now you have to simplify it. So you can basically simplify it like that, okay? You'll have to break that inversion, right, to each input. So the note you guys can make is, if you have something like this, right, and you need to break it, you can break it by changing this sign. Okay? So wherever you change the sign, the inversion will break from there. Okay? So right now there's an end here, right? So you change the sign, and the knot broke, right, into 2. Basically like our MA, you know, when we are doing the reciprocal, right? Yeah. So the time, divide changes to times, right? Something like that, right? Just keep in mind of that. So yeah. So this is a very important property, okay? Please do not forget this. You're gonna be using all this one a lot from now onwards. So let's simplify this, okay? So you have A bar. So I've just shown you the element of this, I mean property of this. So this will change to A of B bar plus that C bar. Okay? Now as you can see, this is all OR, right? So you can just remove the brackets. Right? If there was no O here, you wouldn't be able to remove it. But you have a O, so it's okay. So you can just remove the brackets. Now it's much more simpler, okay? You can see an element here, an element here, and an element also here, okay? So A is A, right? That's the element. So this will basically be B bar, C bar. That's the answer. Okay? Yeah. Yeah. Reverse that. Yeah. But why would you want to reverse it? Yeah, yeah. Usually the questions will be like, two inputs and then inverted. You won't ever be needing to reverse it. Yeah. Okay. But yeah, good question. Okay, guys. Last question. Which example is this? Okay, this was example 5. This 6. Okay. This is kind of a huge one, but no worries. It's actually a very big one, very big example. Okay, so you can see there's a XOR here, right? So let's first look at some properties for the XOR. So XOR is basically something written like this, right? This is Y. So you can also denote it as X, Y bar, or X bar, Y. Okay? Right? So now, in this case, we're going to be placing this as X, placing this as Y. Right? Let's first break this down, and then we're going to move on to this one. So if you break it down, this will look at something like this. BOC bar, okay, plus Okay, let's just denote this as Z for now. Okay, we're not playing with Z at the moment. So let's start breaking this down, okay? So the same denotion. So you can see a huge bracket here, right? I mean inversion here. So I'm going to be breaking from here, okay? So here, or this should stay. BC bracket dash dash, I mean, right? Plus Z. So another note, whenever your element has two inversions, this is same as just your initial input, okay? When you have two dashes, so something like this, right? Okay, it's already time, I think, because this will take a long time. Okay, when is your next class? Next week, Tuesday? Okay, I'll tell Mr. Janif to continue from here, okay? Set. Yeah, because already too late. So have a good weekend, guys. Have a good long weekend, eh? Set, thank you. Huh? Last week Friday, है ना? हमें लेकिन पूरा next week लेते ही है? Next week है? हाँ. अच्छा. लेकिन proposal सिंपल है. लेकिन 10 तक का लागू रहा. उन्हीं वेरी कुछ है हम change कर देंगे proposal. हाँ? ये तो ले. यार. तो तुम लोग next week Friday करेगा. Set. Yeah. Yeah. Yeah, guys, don't worry about your labs, okay? I've seen you guys having like some issues like the delay and stuff, right? So I'll change the lab dates for that, lab 1 date, okay? Yeah. Yeah, I'll change it to midweek, right? Or yeah, because it's in, yeah. Set. Yeah, you should get. Yeah, you should be getting 7 days of time. Yeah, but you guys didn't get it, right? Set. Yeah, don't worry. I'll set that. Okay. Yeah. Yeah, Friday. Set. No worries.